Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Chaos Construction Basics Number 2 by NXT Master, and here are the rules. We need to divide the grid into 6 regions of orthogonally connected cells. And we need to place a digit from 1 through 6 in each cell such that no digit repeats in a row, column, or region. And some digits and region boundaries are given. So first of all, what is an orthogonally connected, regions of orthogonally connected cells? What is that? It means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you can go along these edges here, all while staying within the region. What would not be valid as an orthogonally connected region would be something like this, because these two cells, even though they can get to each other by going through edges while staying within the region, to get to the other cells in the region, they would have to go through a corner or go through an edge but exit the region, which is not allowed. And the reason why I'm doing this actually is because chaos construction is probably one of my favorite rule sets in variant Sudokus. And it's always kind of going to be hard to pick up. I feel like if you have a 9x9 chaos construction, I've not seen one that's easier than challenging level. I feel like all of them because the problem, okay, so 6x6 is you can actually create a 6x6 which is very easy, I feel. Because the number of geometrical possibilities is much lower. Once you expand from the 6x6 to the 9x9, the problem is essentially you would think so it doesn't increase linearly, right? Because if you go from 6 to 6, 6 to 9, but you're going in both x and y directions, like horizontally and vertically, it's going to increase both of those by 1.5. But that means that essentially the difficulty level will have to be multiplied by 1.5 squared, right? You have 1.5 increasing in one direction, 1.5 increasing in another direction. That gives you essentially 2.25 more possibilities for the geometries of chaos construction, which is why I feel like not it's really hard to create a chaos construction puzzle. I feel that is easier than challenging level. But 6x6s, because you have such a decreased amount of possibilities, can very easily have a very easy puzzle. But I also wanted to show you some maybe tips and tricks that you can potentially use for chaos construction. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. The one thing that stands out to me, so these are boundaries, which means these have to be different regions. Every region has to have, in this puzzle, 6 cells, right? Because you have to divide the grid into 6 regions of orthogonally connected cells, which each contain the digits 1 through 6, with no repeats. And so the question is, a lot of times in chaos construction puzzles, you have to basically figure out what cells can be part of a full region. Well, these cells can only expand orthogonally going this way, right? Because you have to have 6 cells in that region. Well, this only has 4. These can't be part of that region because they specifically have a boundary between them. So you have to go this way, and then you can't go up. So where can the 6th cell be? It has to be there. So that's the construction of one region. Now you have something here, which has to basically be part of a region. And it can only be part of this cell, this cell. These are different regions, so it can't be part of that. So you can only go up here. So we know that these parts are part of a region. This has to be a separate region here, so we'll make a different color. And this has to go out somewhere too. So it has to go out that way, which means this 4-cell region to expand has to go that way because it's 5 cells, right? So then we have that. This is a different region than this. So this has to be pink or a different region. So blue has to go either that way or that way. We're not sure. These are 2 separate regions. So we have yellow and yellow here. So this is full. This is done. In the red region, we have to have 1 through 6. So let's put that out. 6 can't be here, here. 5 can't be here, here. 6 can't be here. 1 can't be here. So where is 6 in this red region? It has to be here. One of those 3. That means 6 cannot be here in the blue region. 6 can't be here in the blue region. 6 can only go 1 here or 1 here. So 6 can't be here because of 6 in the row. 6 can't be here because of 6 in the column. So in the blue region, we're going to have a 6 there. What else do we have? This is a different color. We don't know about these. These are different regions. So one of these 2 could be blue. How else do we want to approach this? So these 2 digits, where are they in the red region? They cannot be here, so these 2 digits must be the same as these 2. Okay. These 4 have to be these 3 and one of those or one of those. We don't know which. Okay, yeah, that's probably a better one. How does this yellow region expand? Well, for one thing, you have a 6 already in this yellow region. That means you cannot have 2 6s in the same region. So this yellow region is necessarily blocked by this 6 cell here. Blue can be only one of these 2 for the remaining cell. So one thing is yellow can never go this way, because if it goes this way, first of all, it could try to go this way, except that it's blocked by the 6 there. So if it reaches this cell here at all, the problem is blue doesn't have a full 6-cell region, right? Because yellow would have to go this way to block, and that's not possible. So yellow can reach up to essentially here, and then 5, 6, and that's the bare minimum that it can be going this way. Which means, where can pink go now? Pink can only go this way then. Because yellow can't form a full set here as 6 cells, because it will block blue in both of these cells here if it does that. So again, it can only be at bare minimum this way, which means pink definitely has to go this way in this path. So this is a lot of what you'll often run into with chaos construction geometry. And obviously, as you expand it to 9 by 9, it becomes, you have 2.25 times the amount of possibilities. But here, it's pretty limited in what you can do. So therefore, pink is guaranteed to have to go this way. And it's going to have to be at least this, well, okay. The most yellow you can have is 6 that way. So you're guaranteed to have pink at least go there. And in fact, that actually forces yellow to be this way, because there's no other place for yellow to go, right? Pink also has to form a 6-cell region. Yellow has to form a 6-cell region, and this is guaranteed to be pink because pink can only go this way to expand. So therefore, yellow has to be these 6 cells here, which means that's fully formed as a region. Where can pink go now? Pink, so blue now is done that way, so that's blue. Pink can only go this way now. And these have to be separate, these have to be different regions, because this region goes here, has to extend out that way, so that's 3. It could go that way, it could extend that way, but orange can only go so far, right? Orange can go 1, 2, 3, 4, 5, 6. So the length of orange can reach all of these. But these two have to be green. And if orange went here, there's no way that green could form an orthogonally connected region of 6. So this can't be orange, which makes that guaranteed to be green. So green can't go to any of these 3 cells, but they can reach any of these cells. So these are a possibility of green, possibility of orange. We know this is pink. Okay, so what are the digits remaining in the, we have yellow, we have blue, red, and pink defined. So right now, the one thing that I'm seeing is where is the 6 in the pink region? Cannot be here because of 6 in the row, so it has to be one of these 2 cells, which eliminates 6 in the rest of the row, so this can't be 6. So where is 6 in the blue region? It must be here. We also have a 3 in column 6. Where is a 3 in the blue region? Can't be any of these cells, so it must be here. That eliminates 3 in the rest of this row. So we're guaranteed a 3 here. Remaining digits of the pink. Well, okay. Where's the 4 in the yellow region? Can't be here. Actually, what are the remaining digits in column 5? We have 1, 2, and 5. Which eliminates 1, 2, 5 in the rest of the yellow region. So this can't be 1, 2, 5, or 6. It's 3 or 4. That eliminates 3 and 4 in the rest of the column. So the remaining digits in column 4 are 1, 2, and 5. But this can't be 1 because of 1 in the region. So that's 2, 5, and that's 1, 2, 5 there. This can't be 5 or 1 because of 5 and 1 in the region. So this is 2. Which eliminates 2 here, it eliminates 2 there. That also eliminates 2 in the rest of this row, so the 2 in the red region has to be one of those 3 cells. As we have 6 there, we have 2 there. 3 is guaranteed to be one of these. Remaining digits in column 6, we have 1, 2, 4, 5. So 2 being guaranteed here for the red region means this can't be 2. This can't be 2 because of 2 in the row. No 2 here, no 1 here, no 1 here because of 1 in the row. This can't be 5 because of 5 in the row. Remaining digits of the pink region are 3, 4, and 6. So there's no 6 here because of 6 in the row. Okay, what else do we have? We know one of these 2 digits is 3 because there's no other place for it in the red region, so this can't be 3 here. That's 4, which eliminates 4 in the rest of the pink region. So this becomes a 3, 6 pair, which eliminates 3 and 6 in the rest of the row. No 3 here, that makes us 4, which makes that 3. No 4 here. So that's a 2, 5 pair that way. 4 eliminates 4 in the rest of the row. So 4 also, well, 4 can't be here because of 4 in the box. But where is the 4 in the red region? It can only be one of these 2. Well, 2 can only be in one of those 3 cells. 6 can only be in one of these 3 cells. 4 can be only in one of these 3 cells, which means this is a 2, 4, 6 triplet here. So we cannot have 1 or 5 here. It's 2, 4, and 6 as a triplet, which eliminates 2, 4, 6 in the rest of the row. So this can't be 4 anymore. We now have a 1, 5 pair in the blue region. That eliminates 1 and 5 in the rest of the region. So no 5 here, that's 2. No 1, 2, 5 here, it's 4. 2 eliminates 2 here, so that's 5. That means this can't be 5 because of the 5 in the region. Okay. Remaining digits of row 1. We have 1, 2, 5, and 6. No 5 here, no 1 here because of 5 and 1 in the respective columns. Row 2, we have 1, 2, 3, and 5. No 1 here, no 5 here because of 1 and 5 in the rows, or the columns. And the remaining digits then are 1, 2, and 4. Well, 1 and 4 eliminate 1 and 4 here, so this is 2, which means this can't be 2, this can't be 2, it's 1 and 2. 1 and 2 eliminate 1 and 2 here, so that's 4. 2 eliminates 2 here, so that's 6. That eliminates 6 here. This can't be 4 because of 4 in the column, so that's 2, that's 4. 6 and 2 eliminate 6 and 2 here, so that's 5. This can't be 2 or 5 here, that makes that 3. 2 and 3 can't be here. This can't be 2. 3 eliminates 3 here, so that's 1, which makes that 5. 1 eliminates 1 here, so that's 3, which makes that not 3, that's 6 and 3. That leaves that as a 2. So we have a 1, 5, and 4 already in the green region. Also, this 3 and 5 eliminate 3 and 5 here, so that's 1, which makes this 5, which makes that 1, which makes that 5, and then we'll get the digits here. So now we need to figure out what the regions are here. Well, we have 1, 5, and 4 in the green region, so this cannot be green because this is guaranteed to be 5. Therefore, it's orange, and this 5 makes that a 1. A 3 cannot be orange. We already have a 3 in that region, so this is not orange, it's green. That means this cell is only surrounded by greens. It cannot connect to the oranges, so this must be green here, which means this can't be green because it's a 2. Therefore, to connect to this is orange, this has to connect this way. So that's all orange, and this must be all green. And these are the regions, and we'll fill that out, so it's 1 and 6. And that's a solution. So what are some things? First of all, it's always good to know in chaos construction where regions can expand to. And this is why it becomes multiplicatively harder from going from 6 by 6 to 9 by 9, right? In this one, you're really restricted in where these regions can go, right? This specifically, this lower left corner restricted really where it restricted that this had to go this way, period, because of the way that the boundaries were set up. And that forced this to specifically go in this direction, right? And then you could go in one of these two directions, but this cell was in a different region, so you definitely were restricted in where you could go here by the 6 and by where blue could be. So that restricted where this could go, which means, and we knew this was a different region, so that was restricted where it could go. And then the second part is sometimes you need to find where numbers can be and where the regions can get their missing digits, essentially. So you'll use that quite often too in chaos construction puzzles, because it is a very restricting possibility. But again, there's in 9 by 9 becomes quite a bit less restrictive, because there are many possibilities potentially. But you'll use that quite often. So you'll use where the boundaries block regions, where they can expand to orthogonally. You also have numbers blocking regions, and so that was very helpful there with the 6s here. And then other regions blocking boundaries, right? Just because of the where you have at a minimum where a region can be. And then you have finally just regions trying to reach their digits that they're missing. And that will often restrict where regions can go. So this was actually I feel like this was actually a very good a beginner basics to teaching, because it showed how the geometries can be restricted by various means. And these are actually all pretty they're definitely very commonly used techniques to define the boundaries of chaos construction. I've actually never really thought about it, but yeah, these are all sort of how you can essentially start defining where regions are and how that restricts certain elements of how the regions can geometrically grow. So yeah, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.